Okay, so physics question 4, so it's dealing about the principle of moment. Okay, so the difficult part about this question is that this question involves two pivot. Alright, so I want to find the force exerted by pivot T. Okay, so normally the question that we see normally, right, is all dealing with just one pivot. So one pivot is very easy to solve. Okay, we know that clockwise moment equal to anti-clockwise moment. But for two pivot, it's actually the same thing, just that we want to make into one pivot. Okay, so for this question, we are given a uniform plank of 3 meter, and the weight will be 1000 Newton. Okay, so I converted the 100 kg to 1000 Newton already. The boy or the man that is standing 1 meter away from your pivot T has 500 Newton weight. Okay, so we are required to find the force exerted by pivot T. Okay, so first of all, whenever we are dealing with this type of question, remove one pivot. Okay, so let's just say I want to find the force T, right? Okay, I remove this pivot. Okay, sorry about that. Right, so 1 meter. Okay, so you remove the pivot and replace it with a force. Okay, so this force, let's call it force T lah. Okay, and then we use the moment about pivot R. Okay, then yeah, so clockwise moment equal to anti-clockwise moment, right? So clockwise equal to anti-clockwise. Okay, so look at the diagram. How many clockwise moment do we have? 2, right? So it's 1000 Newton and the 500 Newton, because if we are taking the pivot R, right, this rotate in this way, and the weight of the man rotate in clockwise manner, right? So let's do accordingly, right? So just alright, so 1000 times your 1.5, because it's a uniform, right? So the center of gravity is exactly in the middle, and the man 500, alright, times the perpendicular distance of 2 meter, right? So this will be the distance. Okay, so 2 meter will be equal to your anti-clockwise moment, right? So anti-clockwise moment is only due to your T. Alright, so T times your 3 meter. Okay, so we can find T in this manner. So if you calculate, you should get 1500 plus 1000 equal to 3T. So T is equal to 500. Okay, so you'll get about a force of 8331 or 833 Newton. Right, so force T is 833 Newton. Right. Okay, so we want to find what is the force R acting on your plank, right? So there are two ways. Okay, so there are two ways to this solving of this question. The first method will be the fastest way, and the second method will be a slower way, right? So first method, I'll just use the first method first. Okay, let me put back the pivot. Okay, so where's my right? Okay, so I'll put back the pivot and remove the force T. Okay, right. Okay, so now I want to find force R, right? Okay, so you can see that looking at this diagram, the whole thing is in equilibrium. Okay, equilibrium. So EQM. In physics, when we are talking about equilibrium, it must fulfill two criteria. The first criteria is that there should be no resultant force. Okay, resultant. Okay, force. Okay, second is that no resultant moment. So it must not be rotating, right? Okay, no resultant force means two things. Either it's not moving or it's not accelerating. Right, so for this case, we can see that the whole thing is stationary and it's not rotating, so it's in equilibrium. Okay, so alright, so for this we know that the plank, there are two downward forces, right? Okay, so these are two downward forces of 1000 Newton and 500 Newton. Okay, Then, okay, there are two upward forces that is exerted by your pivot R and pivot T. Okay, so let me remove this and remove this. Okay, so for your pivot R, right, the force is upwards like this. Okay, for your pivot T, the force is upwards like this. Okay, right. So yeah, so you can see there are two upward force and two downward force. Right. So in order to be equilibrium, there should be no resultant force, because this is in equilibrium. Right. So R plus T must be equal to 1000 plus 500. Okay. So upward must be equal to downward force. Upward equal to downward. So you can see that there are two upward force, R plus T, two downward force, 1000 plus 500. Okay. So R plus T equal to 1000 plus 500. Okay, so R plus T is equal to 1500. Okay, so just now we know that the T force, right, the force T, right, is 833 or 833.3. Alright, so R will be okay, so you'll get about force R will be 666.7, or just round it up to 667 Newton. Right, so this is the first method which you will use. Okay, second method you can use is same thing. We just use our pivot, put one pivot. Okay, so this pivot will be at T. Okay, so let me just get rid of this. Okay, so we can see that our pivot is at T. Okay, and my force R, okay, my force R is clockwise. Okay, for my 1000 Newton and 500 Newton, the force will be anti-clockwise. So one clockwise moment and two anti-clockwise moment. Right, so method 2. Okay, so method 2. Okay, so clockwise equal to anti-clockwise. Okay, clockwise will be R times 3, right? Okay, so R times your 3 equal to 1000 times 1.5, so plus 500 times 1. Okay, 500 times 1. Okay, so yeah, so you'll get 3R equal to 1500, 500, which is equal to 2000. Okay, so R is equal to, if you calculate, should be the same. Okay, 1000 divided by 3. Alright, so it's about 666.7, which is equal to 667 Newton. Right, yeah, so you're correct. Okay.